and welcome to Game Day with America Makes. I'm here with Jeff DeGrange of Impossible Objects, and I was hoping I could get an update from you on what's been going on. You've been in the news a little bit lately.
Yeah, this has been an exciting week for Impossible Objects. We actually just released yesterday the announcement of our new CBM 25 system, and 25 stands for 25 layers a minute. And so when you think about the layer size being 18 inches by 18 inches and you're printing a sheet every 2 seconds, the pure productivity that you could get with such speeds. So that's what been our big news this week.
Well, that is big news, though. So I'm pretty familiar with your system, you know, the initial versions of the system that exists. So how does it compare to, is there obviously there's a speed advantage that sounds pretty significant from current state. Is there any difference in the size of components that you can produce, or is it the same build envelope?
No, it's a larger build envelope. Our first machine that we introduced a number of years ago basically had a 12-inch by 12-inch build sheet. This is basically going to have an 18-inch by 18-inch, so it is a bigger build sheet besides the speed. And the speed aspect of it is that our goal is to rival typical cycle times that you might see with injection molding, but eliminate the need for the tooling aspects.
That's interesting. Yeah. So I'm thinking through any changes in built faster and bigger.
Yep.
You know, the other component of that magical trifecta is cheaper. You know, so when we think of, I would imagine due to a speed, you know, being able to optimize speed, I guess they'd be predictions at this point of view on what that means to your ability to, you know, I'll just say generically on a price point of view.
Great question, and that's one of the reasons that we brought the CBM 25 to market is the unit cost of those final parts coming out. Now with the Impossible Objects process, one of the advantages is you have a lot of different material combinations. You could go to high performance material combinations, which certainly have, in most cases, a higher price point. Or you could go to more commodity grade materials that have lower price points. Now, let's just say that whatever, you're on the high end or you're on the low end, depending on where your build speed and the level of effort it takes to get to your final part, we're seeing some incredible improvements as far as the build speed, and then on the back end, as far as post-processing of getting quantities of parts, we believe will open up some new markets in other vertical markets that's been very price sensitive to composite materials. And compared to our earlier system, it's significantly cheaper because of the cycle time.
Oh, that's interesting. So maybe you could talk a little bit. I know I heard the announcement, but know very little about what all was included within it. So when you mentioned previously the flexibility of materials the current systems can utilize. Is there any differences? Is it is the window narrowed in any way because based on what you can do, what you believe you'll be able to do with this new system, based on types of materials, quantity that the current portfolio, I guess, of materials. Does that change any?
So good question, and the answer to that, it actually expands, and I'll explain what I mean by that. So when you look at the CBM 25, is that the way that we flood coat powders onto the fiber sheets is the same. It's just moving faster. Now we have a number of material offerings, but that can easily expand to a lot of other what we call powdered materials or matrix materials. But on the other hand, we're going to a different print system. We're going to piezoelectric print heads, and besides being very reliable with those print heads, that opens up opportunities to do functional inks and some very interesting things with functional inks with that type of print head. And so I think you'll see the material combinations that you could do with this next generation machine, the CBM 25, open up a number of other new material combinations that are unique to certain vertical markets.
That's interesting. Yeah, one of the things that's fun about doing these is getting to dig a little deeper on things that I'm interested in but don't honestly know a whole lot about. So Can you talk a little bit, maybe, so it sounds like faster, cheaper,
More
larger,
options.
more options. Everything's trending in the right direction here. Question on maybe more on the material side of the house. Where do I customize materials? Is that something I work with you to do? So if I'm thinking of new markets and how you might be able to penetrate into those new markets, is it development work within your organization, or is that third-party development that's done?
So typically the answer to that is if there's a need for a different material combination, whether it's through a government contract or through a private industry, we will typically work that at Impossible Objects. But we have university partners and other types of institutes that helps us with certain aspects of that. So it's a partnership that we have. But ultimately, we understand it's basically a wetting fluid, a fiber substrate, and a powder. And you have all these interactions that you have to do. And we got the base knowledge on that. But there's certain aspects of that that people outside the company can really help us accelerate that development activity.
That's fascinating. Is there any? So everything sounds, fascinating as far as, I think there's always been tremendous potential, that differentiates the system and the parts that you can produce. We worked on some project, or you've worked on projects for us and in particular, I think of some of the work you guys did in the Mammals program on aircraft sustainment. And it naturally fits well into certain application spaces, but it hasn't found its mass market per se, and I'm sure that's some of the reasons you addressed were addressed in the system that you ended up producing. What do you think this opens? What market does this open up for you?
Well, I can speak to where we're at today, and I think that some of the key applications that's really pulling this technology forward. The first one happens to be for electronic tooling. You think about items that have printed circuit boards that may require a wave solder pallet and various types of electronic fixturing. Tooling is a great insertion point. It's that type of tooling sees temperatures at 230 degrees C, goes through chemical washes after so many duty cycles. Our materials in this particular case is carbon fiber PEEK, so it meets all those requirements, and we can actually make tools and get them to those contract manufacturers in short order. And so we're seeing for high-value tools for the electronics industry as being a key application today, and that being a growing market. The second application happens to be for unmanned or drone, both for defense and commercial, because we have similar strength to weight as aluminum, 60% lighter than aluminum, and for anything that's unmanned, that's a good thing. You take weight out, that gives you extended service life, more payload, or all the above.
That's interesting. So I think there's a couple of big trends that we're seeing, just I think globally take shape. One is electric vehicles. That's certainly a space. There is the area of attritable aircraft, and there's a variety of different application use cases there, as well as personal aircraft, and moving towards we're not quite to the world of the Jetsons yet, but we're trending in that direction. And composites are going to play a major role in our ability to do that, purely from a weight and an ability to produce components at scale and size and formats that we need. Do any of those? Are those markets? It sounds like you talked a little bit about drones and things like that. Where do you see yourself aligning to those markets?
Those are all emerging markets. So I'll give you a couple examples here. So with the air mobility market, the flying cars, the Jetsons, right?
Yeah, I couldn't think of the name, but that's it.
Air mobility. So we're actually working with a company out in Salt Lake City by the name of Electrifly, and they're making a one-person vehicle, and they've used the I/O process to make composite parts to get weight reduction to get their air vehicle under 55 pounds. And it doesn't have to go through the level of certifications under that weight. So we're engaged with air mobility. And that could be a whole new growth field in that particular vertical. for obvious reasons. When you say electric vehicles, well, this is basically still kind of in formulation stages, but where could the technology fit within in the EV world? Well, batteries. Battery cases don't necessarily have to be rectangular metal cases. Since we're an additive process, we can make an organic shaped battery box with using a thermal set. So it means that you can make an organic shaped battery enclosure case, put your batteries in it, and in the event of a fire, the fire would all be contained, and you're going to be half the weight of a metal case. So I think there's opportunities there.
No, it seems like, and there are spaces where I think we're all trying to understand how does additive fit in, and if so, where does additive fit in? With many of those applications that we just talked through, price is a big component of that. So where I think it's logical that additive can provide an advantage, if it doesn't meet cost requirements and expectations, it's going to be a problem. So it sounds like you're squarely trying to address this via the new machine.
So, and that's one of the things that the new process offers. It's productivity. It's going 15 times faster. The end goal here is to meet speeds that you would see, cycle times in seconds. We have a little pocket pallet that we print in 15 seconds. So as far as productivity and output or throughput, that's what the machine gives you now. But you say, okay, what about those materials you run in those machines? Are they expensive? Well, depending on your application and depending on the requirements of those applications, you can find lower cost materials that you can run through that in order to meet that lower unit costs that are so many industries need to have. So those options are there.
Sounds fascinating. Fantastic to get an update from you. Anything you want to leave us with? How do I make sure I'm staying up as a community on what you guys are doing and at the journey of getting this new system out to the streets?
So I was going to say that for all of you that happens to be here at the Rapid Show 2023, stop by our booth to see the equipment, get some free samples, get some material data sheets, and we could pick up some discussions with you there. Booth 4024.
Perfect. Thank you very much. Thanks, Jeff.